My name is David Robinson. I work here at the Glenville Wake Water Treatment Facility. I've been for over 28 years, and this is the day in life of a water treatment operator. Okay, this is the operator's control room. The first thing we do when we enter this room is we're monitoring tank levels as far as Cliffdale, Wilson Street, Eastern Boulevard, Clinton Road, making sure these tank levels are at a certain level to make sure there's enough supply and demand met for the public. We're also, what's a lot important, we're looking at Fort Bragg. We feed Fort Bragg every other day and Spring Lake. So one day we'll have Spring Lake, well, in Harnett County, which we share with them. We're looking at system pressure. System pressure will tell us pretty much where our tank levels are at. Normally our pressure, if it's around 112, 111, we say probably don't have enough on pumping to the system, so we'll actually engage and cut on more pumps to bring the pressure up. Also our clear well, which the night shift operator, when he comes in at night, he'll make sure his purpose is to make sure he gets enough supply and demand in the clear well so the day person or the day operator has enough to use to feed the public, make sure the public has an ample supply of water to use throughout the day. Testing, of course, is done every hour, on the hour, sometimes in between the hour. 1 hour could be 10 tests, another, and it depends on what's going on in the plant, what's happening that day. Sometimes it could be, just a normal day, or if you got a rain event, or, a main break, or there could be several more tests, done throughout the day. On average here at Glenville Lake, we treat about 8 to 10 million gallons a day. Hartford is normally between 25 and about 30 million gallons a day. Of course, we switched for the monochloramines years ago, which is the addition of ammonia and chlorine. And of course, disinfection is probably the main best way to get free of any disease-causing organisms, kill bacteria, viruses. It's the most important part of a water treatment facility. A raw station is what naturally raw water in a natural state comes into. That's why we bring raw water into a water treatment plant, and that's where the beginning process starts. Treatment process, of course, this is a conventional water treatment plant, which consists of coagulation, flocculation, sedimentation, filtration, and that's raw water which enters the plant, and once it goes through them stages, now it goes to a clear well, which is a storage facility. This is where we meet the supply for the public. If there's any emergency, such as a fire, that we have enough in storage and on demand to do anything we need to do throughout the day. We're at the sedimentation basins. This is the beginning process where the coagulation, flocculation happens, where the raw water enters the plant, is introduced to ferric sulfate, which is a coagulant, introduced to lime, which is a pH adjuster, and carbon for taste and odor. These are sedimentation basins. These are after the stage of the coagulation, flocculation, and then the sedimentation basins. We want the floc, which forms to a solid, become heavy and dense to where to fall out in the sedimentation basins, so reduce the load on the filters once it enters the plant. These basins, we wash these probably after 3 to 4 months to make sure they're clean as possible. There's approximately 170,000 gallons in each basin will pass through here. We have 12 basins just like we have 12 filters. And this is part of the process we do to achieve safe drinking water each and every day. Okay, this is water when first entering the plant, our raw water stage and on our beginning stage. This is also our ending stage when we pump it out to the public. And what we're doing, we're hourly checking for any changes in the water quality at any time. There's a lot of samples that are being checked on the hour. There's a lot of checks that we made between in the hour. But this way, with the running continuously, we can get anything that changes immediately instead of having to cut a faucet on or off. And we're checking for quite a few things: chlorine residual, turbidity, pHs, temperature, everything that will affect drinking water. For example, these two first faucets are the beginning stage. That's when the raw water first enters the plant. In this stage, we add ferric, carbon, and lime. Coagulant is a particle or chemical that causes solids to clump together. Carbon is for taste and odor, and lime is for pH adjustment. So this will be the beginning stage. So each faucet represents each stage in a water treatment plant. For here, we have our pH probe, and the purpose of our pH probe is, of course, to monitor pHs, and we have our buffers to make sure the probes stay in parameters of our pHs, whether they're low or high. We keep them calibrated to make sure they're adjusted to pH as fast as possible. The partnership of safe drinking water has been pretty great for us. It gives us sets us goals and parameters that we try to achieve every day, and it's based on turbidity levels. And turbidity levels is the cloudiness of water. So here, of course, we want the lowest levels every day, and we achieve that through good hard work through the operators here. Since we've been involved in the safe, Partnership of Safe Drinking Water, we won the award, I think, if not mistaken, every year. We were the first to win the EPA's Directors Award. I know that several times we placed several times in Best Taste Drinking Water several times. So we've done a great job here in what we do, and it's due to the operators' hard work.